Before we get to today's lesson, let's work on remembering our exponent rules, because this is going to be really helpful in a second. Okay? When I have a power raised to a power, that's our power of powers exponent rules. What do I do with those numbers?
Add.
Multiply them, right? Multiply them. So it becomes x to the 6th. If I have 2 to the 4th raised to the 5th, what does that become? 2 to the 20th, right? Okay, do you remember that? So what if I had x to the 3/2 power? Am I allowed to go backwards with that and say that's really x to the 3rd raised to the 1/2 power? Am I allowed to do that? Is that also the same as x to the 1/2 power raised to the 3rd power? If I multiply those two, do I still get 3 over 2?
Yes.
Yes. Okay? Now, you're going to know which order we want when we start our examples today. It's going to be very clear which order we want. But I want to make sure you know that both of these are true, first of all, and I wanted to make sure you remembered this exponent rule. Fair enough? Yes? Okay. So let's start with this example right here. Now, how many variables do we normally have in a problem? 2, right? X and Y. And if we were just looking at one side, we normally have just one, right?
Yeah.
One that we're trying to solve for or something. How many variables do I have in this problem? 3. I've got a Y, an A, and a T. So I hope you realize that our goal here is not to solve this problem. We're not trying to get it X equals or A equals. Well, especially since there's not an X, because we don't want to get it X equals. Okay? But our goal is to get this into an exponential form that we can recognize whether it's exponential growth or exponential decay without even having to look at the graph. Is everybody clear? So what we want it to look like eventually is y equals a 1 minus or plus some value and then raised to a power. And today we'll call that power t. Eventually, we're going to call that power t for real, and what do you think t might stand for? Time. Okay? How might we measure the time in this particular problem?
Minutes.
Good guess. Keep guessing.
Hours. Days. Years.
Years. Milliseconds would be fun, but usually when we're talking about stuff like this, we're talking about years, just so you know. Okay? What do you think the R might stand for?
Radius.
Running.
Running is a good guess. But think about this. 1 plus running. Okay, good guess.
Rate.
It's a rate. Okay, a rate, an interest rate most likely. Okay, but that's the form that we want this in. Is this in that form right now? No. Is this equation in this form? Okay, so one more thing before we go on. One of these, either the plus or the minus, is going to be exponential growth. And one of these is going to be exponential decay. So I want to make sure, let's go back over this. This was from the other day, but let's make sure we understand. That's what growth looks like. How could you tell that for sure? Yeah, it's rising. As our x's increase, our y's increase, right? So what's going to happen with this other one?
It's going to fall.
As x's increase, y's decrease. Now, did you see how I was careful to make it go through a specific point right here? What point is that?
1.
It's a 1, right? 0, 1 is the point. If x is 0, then y is 1. That means if my exponent is 0, that means anything to the 0 power is what? 1. And we've talked about that quite a bit, haven't we? It's in our exponent foldable from last semester. We even talked about it a couple days ago as well, right? Okay. So this one would be called which one? Growth. And this one would be called what? Decay. Okay, exponential growth and exponential decay. What do you think makes this one growth in the equation? It's going to be the plus, right? So my b value, this value right here, my base, that value has to be what? If you're telling me it's 1 plus something, it has to be greater than 1. That's exactly right. Okay? Then tell me about the b value for the decay. Less than 1? and greater than 0. Very good. Okay? Now, some people say, oh, it's a fraction. 3/2 is a fraction, isn't it? But 3/2 is greater than 1. So we just have to be careful with our vocabulary. Fair enough? All right. So this one's going to be growth, this one's going to be decay. We need to be able to tell by looking at this b value if it's greater than 1 or between 0 and 1. Now, we can look at the base of this problem right now and say, oh, that's less than 1 and greater than 0, so I know it's decay. Except look at its exponent. My exponent is only supposed to be an x, or in this case, a t, right? So we have to use our exponent rules that we talked about first thing, and we have to figure this out. Okay? So watch how I'm going to rewrite it first. A times 0.5 to the 1 over 28 power raised to the t power. Does that match what we first talked about right here? Why did I pull the number in instead of the t? Yeah, I don't know the t. The t is what I need, right? Remember I showed you this is the one we need it to look like? I need the t out there. I need to pull the number in. Do you happen to know 0.5 to the 1 over 28th power off the top of your head? Oh, me neither. But what?
Calculator.
Oh my gosh, we can use a calculator to figure it out. So, with your calculator turned on, right? You're turning your calculator on. We're all turning our calculator on. After we get it from the calculator home. We want to say 0.5 raised to the... Now look what I did. I made it look like a fraction. I don't want there to be any question whether that's in the exponent or not. So I made sure to put 0.5 raised to the 1 over 28 as a fraction in the exponent. Fair enough? Is that required? It's not required, but it sure helps in your visualness. Okay? So what is this? So if I'm going to rewrite it, I'm going to get A times 0.975549 to the t power. Does it look like this yet? No, because it doesn't have a 1 plus something or 1 minus something, right? Yeah. Can I make this be a 1 plus something or a 1 minus something? Yeah. Very easily, right? First of all, is it going to be a 1 plus something or a 1 minus something? 1 minus something. What does that something have to be, you think?
Oh, that a 0. Like 3.3 or no.
How did you get that? Didn't you just minus this from 1?
Yeah.
Yeah. So what's 1 minus that number?
Oh, I have a calculator.
Yeah, we all do. So 0.024451. You okay with that? So now, what I want you to be able to do is tell me whether this equation is growth or decay, and by what rate. Decay. Why do you think it's decay? Because it's minus. It's 1 minus something, so this is decay. Yes. Okay, that's where we're going to get the percent. Now remember, it's percent. Is this a percent right now? Or is it a decimal? It's a decimal. So how do I convert it to a percent?
You have to move it 2 places.
So it's a place value issue, right?
Yeah.
So we need our place value to be
2 places.
mathematically we're multiplying it by 100. Remember that?
Yeah.
Okay? So by what percent is it? And here's what we're going to do. Wait, before we go on too far. We're going to make it a whole number percent. We're just going to stop at the whole number percent. We need to round it correctly, but we're going to make it a whole number percent. 2%. Everybody okay with that? 2% milk is delicious. Chicken milk, 2% chicken milk is also delicious. Especially if you order it from Logan's. Right? Okay. Was everyone here when she told the story? She tried to order chicken milk at Logan's. They don't carry it there. They told her.
I wonder what the waitress was like.
They had to go ask the manager.
He was like, I'll go ask the manager. And he goes and asks the manager goes, chickens don't produce milk. And he goes, oh, yeah. And back, we don't have chicken.
Was she actually looking for chicken milk? Or was she trying? Or was it
She was being silly, but she thought the waiter would get it, but then the waiter thought it was serious.
Can you tell names on this? Because that's pretty funny.
Savannah.
Oh, you.
Oh,
yeah. Yeah. Okay, so does everybody understand why this is 2%? If I take this number right here, and I have to figure out what its percent is, I multiply it by 100. Now, some of you I know to move decimal places, but it's a place value issue, and that scares me a little bit mathematically. Okay? So if we're multiplying this by 100, I end up with 2.4451%. I just want the whole number. I want you rounding it correctly. If this said 2.5, what would you have written? 3%, right? Is everybody okay with that? So this is decay, and it's decay by 2%.
Okay.
All right? All right, one more example, and then I'm going to let you go at it, okay? Y equals A times 2 to the T over 3 power.
Okay.
So first, what do I have to do? Separate your exponents, right? So separate your exponent. So what is it going to become? 2 to the 1/3 to the T power. See how it's dividing by 3?
Yeah.
If it was multiplying by 3, you're right, it would be 2 to the 3rd. But since T is being divided by 3, that's really T times 1/3, right? You okay with that?
Yeah.
Okay. Now what do I do?
multiply.
Do I multiply the 2 and 1/3?
Oh, no, not multiply.
Okay, good. 2 to the 1/3 power, right? What is 2 to the 1/3 power? 2 raised to the 1/3 power. Is that what you got right there? 1.25992?
Yeah.
So A times 1.25992 to the T power.
Yes.
Now I need to make it look like that. I need it to be either 1 plus something or 1 minus something.
Okay, so 1 plus 2.25992.
Yeah, that was super simple, wasn't it?
Yeah. Whoa.
I'm woeing as if I was a horse.
Okay, if it's a constant, it's plus.
You okay with that? This was already above 1, so I needed to be 1 plus something. And it's whatever something was after the decimal here. Okay? So tell me if this is growth or decay. Why is it growth? This number is greater than 1. And by what percent? By what percent? 26%. Remember, if we're multiplying by 100, it's going to give me the first 2. Here I multiplied by 100, but there was only the 2 there. Okay? Is everybody okay with this?
Yeah.
You're feeling confident?
Yeah.
All right. Go ahead and work on the questions. You have a couple minutes before the end of period. Work on the questions and see how many you can get done before you leave. Okay? Any more questions?